Recording. There we go. 3, 2, 1. What's going on, everybody? How
Hello.
is everybody doing in here? Feel free to say hi.
Hi.
Yeah, Sentinel. I see Sentinel joined. Okay, so today we're gonna talk about and feel free to interrupt me whenever you want. But I'm just gonna talk about the general kind of I'm gonna try my hardest not to make it seem like it's some kind of like wet dream, like because I got a lot of comments on the last video, like, what the hell you mean you're starting a research institution on Discord? What does that even look like, right? Like, what are you, like, what are you doing? So, this is it's kind of you guys have to be able to like attach your imaginations to this, with a little bit, you have to be a little bit creative with it, and think about it as like a perspective idea, right? It's not something that like I secretly have a ton of cash and I'm just gonna like make an Andrew Tate Hustlers course or whatever, right? So the idea really, the main idea is to organize things around questions, and I hope you guys appreciate the British spelling, okay? But organize around questions and not disciplines. So not basically the idea is not to have some list of like Erdos problems or the Riemann hypothesis. We're gonna solve this whatever with AI, like Claude recently just but got like the percentages on 2/3 of the primes are on the critical strip or something, whatever. It's more so like here's a set of open research programs, and this is work that we can kind of do today that remains relevant for a technologically advanced civilization, just in general. Okay, so I'm speaking in kind of platitudes, but also like, and I'm kind of semi speaking out of my ass as well. But I feel like that's pretty important for people who want to work on important problems. And there's a bit of kind of a leap of faith, if you will, into, hey, I don't know that much about theoretical physics. I don't know that much about mathematics, but you have an entire internet at your disposal, and you have these incredible resources that have already been made. If anybody has viewed like the websites and that have been attached to it, like as links or whatever. By the way, can you guys talk? Is the audio working? Is somebody? Yeah. Okay. Just making sure. But yeah, so that's the philosophy behind it. And and by the way, feel free to interrupt me whenever. But kind of the unifying question behind everything is what mathematics, physics, computation, and institutional infrastructure would be required for a technologically advanced interplanetary civilization. Now, that's a massive question, and like this sounds like kind of an Elon Musk, like I might be this massive fan of Elon Musk, and I don't know, just it's kind of like I'm not necessarily trying to like make this crazy scam like idea. Like this is, I mean, everything that I do in the jetspace is for free, and all of the references and material here for like people that are just joining. My audience is a lot, like you guys, I shared the stats with the audience. A lot of them are a lot older than me, which is kind of cool. And I think there's a lot of like self-teachers, self-learners in here as well. So like I'm not necessarily trying to start this like company or trying to start this like early Facebook type of thing where you have this massive like cesspool of like taking competitors, like people that they're employed, or taking stuff away from academia or whatever. But it's just kind of like a thing that's developing in parallel, and the core like forecast, if you will, would be, or the core like I guess discount from the future that we're trying to gauge is interplanetary civilization as kind of this idea. Yo, what's up, Illuminator?
What's up?
It's the new file from oh my god.
What's up, dude? Anyways, so like for Illuminator that just joined, feel free to ask any questions at any time. it's kind of a fluid thing. So the whole idea is geometry, random systems, probability distributions, learning. What does it look like to topologically protect a network? And the geometry of computation itself. Those are all kind of like open problems that I think would be central to what an interplanetary civilization would want or what would need to answer, right? Because as you have these infrastructural kind of demands that we're going to need for, mining asteroids or capturing asteroids, or even the energy storage. I think even like NVIDIA had some stuff with like data centers in space, like recently. So, like all of these things require the mathematics and the physics underlying and the engineering problems that are posed by mathematics and physics, and the discovery and the control of these types of quantum computational systems. So geometric structures inherently help us navigate through complex systems, and the whole idea of covariance and regression, right, where you have some kind of expected hypothesis testing, or like this is the expected distribution, right? And in physics you'd say you make a discovery if like you have a above 5 sigma event, like you say this is a new particle because it breaks the expected distribution or the expected statistics of how these particles would interact with our detector. It's the same thing. Like, how do we move beyond covariance? How do we move beyond regression? That's another thing that I made that finance resource on my website as well. Because there's a lot of differential geometry and statistics and ways to generalize things like connections, which give us a lot of all sorts of geometric structures to play with. So the next thing would be, by the way, are there any questions so far? Would anybody like to say anything? I just want to open it up.
Nothing seems like.
So the main framing here is about like space exploration.
Yeah, I mean that's like kind of that's like the one piece, right? Like that's like the goal. That's what everybody's trying to get, right? Is the interplanetary civilization. Like that's, I think, the main framing of what motivates me, and I think it motivates a lot of people as well. But it's like hard to keep it from becoming this like science fiction type of thing. So that's why I emphasize, grounding things in mathematics and physics. Anything else?
But there's still space for like other fields. Like if someone's doing, for example, I don't know, some kind of biochemistry research, of course it's going to have an application in the future on a spacefaring civilization. But something like that, my question is, would something like that belong here as well? Or does it all have to specifically be tied to some kind of space exploration?
Absolutely. I think those things are emergent from, I mean, they're complex systems, right? So like these things like biological engineering, or, reverse aging, or immortality, right? Biological immortality, is that something we achieve as well? Like, I think those are also concerned with what a spacefaring civilization would be, some of the goals of that as well. So yeah, of course, absolutely.
Okay, thank you.
Yeah. Okay. I'll just move on to the next slide. Another idea is dynamical systems. Bro is not the thinker.
Son.
I know this guy. I know him IRL. He's funny. So yeah. Sorry, that caught me off guard. But so dynamical systems and stochastic physics. This a lot of people, I would recommend looking at the reading list as well, the 5th volume of Landau, because there's a really, really good piece of writing there that talks about the emergence of many body systems and open, closed types of systems, how we choose to describe those things, and how stochastic dynamics can evolve on manifolds. This would be more under like kinetic theory for diffusion processes that we choose to define for systems that are like not in equilibrium. But really, the discussion, I guess, would be how a complex system can admit simple macroscopic descriptions, or are there geometric or variational principles for non-equilibrium systems in general? So, and of course, one of the interesting things comes from Parisi and Wu with their supersymmetric formulation of, well, it's called stochastic quantization. And you can think about it having these emergent, from classical dynamics, you get emergent quantum mechanical types of descriptions of like reality. And basically from like noise and Langevin type dynamics, but you take variational principles that apply to how the fluctuation of particles to then give us these emergent statistical behaviors, and it goes further into statistical field theory and all these things. But so that's another route, is the dynamical systems and the stochastic physics route, multi-scale, multi-physics dynamics as well. Okay, so if there's not anything on this, I can move on. Okay, fundamental physics. This is my favorite, simply because this is the kind of like stuff that I've been looking at YouTube University for a very long time, since I was like, I don't know, like 12, like looking at all of the, looking at all of the, the string theory videos, that like as a kid, all that propaganda, quantum gravity and like whatever. So, but really, and this goes back to a guy named Jim Simons as well, who started, the Flatrion Institute and the Renaissance Technologies. If you go to any of his stuff online, if you look at anything, he doesn't have much writing, but if you have time, you should watch some videos of what he talks about and how he operates his company, or how he operates his institute, because he's always talking about fundamental physics, fundamental problems. And like fundamental problems are super important because they are essentially what allows us to like it's essentially what allows us to make mathematical and physical predictions about our universe. Whether it's like the 511 kiloelectron volts, splitting of or pair production of some gamma ray, like that was predicted exactly by Dirac, with math. Or something like soft matter physics. Like, how do we engineer these like different patterns? Like, as we're sputtering these particular semiconductors that are going to be used in God knows what, right? So you have these really important problems, like the origin of neutrino mass, the geometry of the standard model, the standard model itself, being this. SU3 cross SU2 cross U1, and confinement, particle confinement in Yang-Mills dynamics, the dynamics of Yang-Mills fields, the geometry of quantum matter, how string theory and how holographic theory applies to condensed matter systems, or even just emergent statistical properties of matter, and then also open quantum systems. Like, what happens when we have, quantum mechanics in it that's not in equilibrium? How do we even just describe this? Like, and that's important for like plasma and for magnetohydrodynamics, for combustion physics. So, what observed structures are forced by a deeper geometry, and then what is genuinely new versus computationally accessible as well? Those are really important problems. Does anybody have any comments? Okay. And by the way, for the people that are talking in chat, you can feel free to unmute if you want. It's a little easier. I'll go through and look at the chat in a second, but yeah. I am recording and you can speak if you want. You'll show up in the video. But yeah, so lastly, or I don't think this is the last one, but there's also energy propulsion, space physics as well. So I kind of mentioned this mostly from fundamental physics a little bit, but there's also autonomous scientific spacecraft, making a bunch of making like a swarm of like spacecraft that launch from low Earth orbit, and that's going to look complete. That's going to change everything, like how we do interplanetary just everything. So, and also distributed spacecraft infrastructure, kind of like how crypto, is this massive consensus network that's distributed with like this reward system. Like you could think of all of these like autonomous, you could think of like all these autonomous systems as this. So as trying to do something like Bitcoin. I don't know. I mean, there's a lot of crazy ideas that are there that sound fantastical. But really, I mean, it's part of the research process. I would argue. So spacecraft capable of scientific reasoning, and distributed systems. How do you make sure that they're coherent under latency? It becomes a latency engineering problem as well. Also, the mathematics of future economic systems. We talked about this for a long time last night. I mean, there was a nice conversation. If anybody wants to chime in as well, like thoughts that they have from yesterday, but interplanetary markets, yeah. The geometry of liquidity engineering. What does it mean to provide liquidity? I think a lot of interesting places to play around with that anybody really could get into is gambling markets. Gambling markets, they have you can stream the order book data and like the order book messages and all that stuff, and play around with some algorithms, and just it's a good exercise in learning how financial markets really work, because they really are like these networks of collateral, these machine type of economies that like are trying to get some information or get some edge on some information that another one does, and achieve some kind of equilibrium. So I guess the question would be, what would be the correct state space geometry of the market, and how does markets function when instantaneous global prices are impossible, right? Because relativity is a thing, and in high frequency trading, people have different opinions on what the price is, and of course, if you're working on the millisecond, microsecond kind of scale, your microwave beaming and your FPGAs, and also the fiber optic cables have the speed of light travels a little bit slower in fiber optic cables. So like that's another thing to keep in mind. Like price itself becomes this very you need a lot of science to describe what price really is at that really high frequency scale, and then as there's an entire continuum as you go for like medium frequency and low frequency trading as well, where it becomes more macroeconomical. Okay, the institution itself is kind of a mathematical problem as well. Just from a how do we even organize it, right? If you have 55 gigae, what is that? An exoplanet? Is that a habitable one? That's a habitable one, right? Yeah. Anyways, Diamond Planet. Yeah. Yeah. Okay, I know what you're talking about. I used to watch those videos when I was like 6. Those like exoplanet videos. But anyways, so yeah, I get really easily sidetracked. Yeah. But yeah, so there's like topology of knowledge, scientific memory. What does a healthy research network look like geometrically, and like how do you make a scientific record that's both navigable and trustworthy? This is a pretty important thing as well, in my opinion. This isn't my forte. I'm not super good with data structures and all of that stuff. But yeah, that would be another thing. So the idea is, basically surrounding everything, you'd have some like library type of economy thing. You'd have verification, some kind of institutional memory, and you'd need geometry, probability, dynamics, and physics to be the core of things, and computation to then lead to engineering, to then lead to economic systems and other things. So my advice to people, that are just in here. There's not super, like, we're not super completely organized, obviously, if you look at the cesspool of general. Or if you look at the low quality content, we're all kind of just like, we're a bunch of young, like 20-year-olds. There's some people that are, the distribution's a little bit older. Some people that are like just getting started in like university, like some sophomores, and so like this is kind of that's what to keep in mind. Like that's what this Discord server, that's the demographics and the kind of the stuff. But I think the talent that is concentrated here, it'll be pretty interesting to see what comes out of this. And so, starting with problems with pieces that can be attacked today, that's the first place to start with any kind of research. That's, self-started or unusual joint activity detected in jetspace. Interesting. So how's it going, Clippy? But yeah, so you have, you want to avoid defining the institute on a speculative proposition.
Again?
What's up? Oh, yo! Dude, yep. How's it going?
Yo, and so many.
Yeah, no, by the way, I'm in the middle of a YouTube video, so if you want to, you just...
oh, what's up?
What's up,
oh,
dude?
My bad.
No, you're good. He's the guy that I did the Minecraft video with. Anyways, so yeah, so you want to build a research graph, not necessarily a list of promises as well. I mean, this is just kind of the principle, right? These are the working principles. So I guess we could open up for discussion, and feel free to debate me on everything. And, I mean, you could attack me if you want, like, tell me, like, yeah, you're just this massive LARPer or whatever. I really don't care. So, just go ahead. Like, which programs do you think should be prioritized first? Be substantive, right? What are the strongest cross connections? What does success look like for a research program? Like, not just accomplishing some single theorem, right? Like, think about the Langlands program, how it's something that, is trying to find the correspondences between like analysis, geometry, and algebra, right? And like the intersection, and use tools from all of that, like something, and even quantum field theory. What does success look like for a research program? What should the institutional layer, like memory verification libraries, how should it be built in parallel? What would be like things, and also like what should be deliberately left out of this and why? So I'll open it up to anybody who wants to comment. Or if not, like, it's cool as well.
Yeah, I think that a big difficulty with this kind of institute is going to be catching people up to speed with your research. So if there's you can imagine in this group, there's going to be cells that are doing independent research on different things, right? And the thing with research is it's pretty technical. And so if you need to organize it, this is kind of designed, from what I see, in a way where anyone can jump into a topic and do research on that topic. What would probably be helpful is if you had a guideline on how to arrange the information that is necessary to understand your research and to contribute to it, so that each of these cells, people could immediately jump into it, and they wouldn't necessarily need to worry about okay, now there's 5 books that I need to read, and I need to ask these people exactly where the code is that I need to modify, et cetera, et cetera. It kind of needs to be systematized.
Yeah, no, that's a really good, I completely agree with that. And on top of that, just to add something, getting into something there's some lower skill, or not lower skill, there's lower barrier to entry kind of options like in math and physics in computation that people don't necessarily know at first. So maybe there would be a nice getting started, here's some numerical analysis types of things, because numerical analysis isn't that hard to get started in, and learn to compile a basic C++ program that does automatic differentiation or something like that, right? And of course that might be out of theme with what specifically we want to do, but then again, that's research. Research is very messy. So yeah, I completely agree. I guess to summarize what you said as well, in my own way that I processed it, was the barrier to entry should be kind of, we should allow like quantum tunneling through the we should allow quantum tunneling through the barrier. If that makes sense.
Yeah, you should make it so that if someone wants to get involved with someone else's research, there's like a something they can look at. You know, they don't just have to ask them like, okay, what about this? What about this? They can just hop right in basically after
you
doing
can
the
make-
necessary reading.
You can make repositories as well for this. Works
Yeah,
very
exactly. Something like that would be good.
Yeah, that would be peak. Is there anything
like,
else?
on GitHub, right? Yeah. GitHub.
Would you like want it to be accessed like just through the server or what?
No, not really. I mean, again, the video that I made with that kind of clickbaity title was I'm starting a research institute in Discord, right? The word is starting. Doesn't have to end in this Discord, doesn't have to end like it's something, it's like a network of people that have already been here, that we all have already kind of talked about our research problems. And like, and there's a lot of people that I've worked with in this Discord, like outside of it. And so like, yeah, of course, like it doesn't have to be in here. I'm not like saying like it has to be in here. It's just, I just kind of want to get the momentum going and like people's imaginations and creativity kind of, and motivation for like, reading a little bit extra beyond like what the standard university curriculum is going to tell you, or even what a standard research institution, like their YouTube videos that they put online. Because, there's like the IAS, there's Perimeter Institute, there's the Fields Institute, like the Simons Institute for Geometry and Physics. There's like all of these like YouTube videos that you have access to as well. So I'm not necessarily saying that like, everything would happen in here, like in this private institutionalized way, but it's kind of like an emergent thing. So yeah.
Can you hear me?
Yeah, what's up?
Oh, sorry, you can go ahead. Whoever else was talking.
Oh yeah, no, I was just saying like we could make like regarding that user targeted based channels. So like splitting it up, as you're saying, like you don't want it to be an institution, or you do want it to be like an institution. You can make like different categories of people who want like research on different topics, and kind of like split them up into different groups. Would make it like much more easier.
Yeah, I think that's definitely something that's missing. But I'm open to.
I could do that.
Oh hell yeah! Okay, perfect. Somebody else was talking.
Oh, that was me, Yoshi.
Oh yeah, what's up, Yoshi?
I was like lucky driving.
Nah, you're good.
I was lucky like driving back home, so I couldn't like listen too intently.
Nah,
But
you're
like,
good.
I'm not sure if you've answered this, but like, what is like your, I guess like your end goal, or like, just like end goal, right? Like for starting something like this, right? Because I feel like it would definitely help with like having a really like, I guess like a relatively clear picture about like what your results, like what the results you would want from something like this would be, right?
I mean, I kind of chase horizons, right? Like, if you fall into a black hole, right? Like you're never eventually like your time is gonna go up to infinity. You're gonna see the end of the universe like at the horizon. You're gonna get like spaghettified or whatever, right? So like that's the whole idea. Like the end goal itself is a horizon. You're chasing a horizon, and like in chasing the horizon of like what a spacefaring interplanetary civilization would even look like. Like to me, that kind of is kind of a scary thing, because it's like, man, it's not that we'll never get there, but it's a direction, right? And so that's all I see it. I see it as like just simply a direction, and the end goal is kind of an ideal, maybe. I don't want to get too philosophical about it, but it just makes me overthink.
Yeah, okay,
but,
I see, that makes sense.
yeah,
Yeah.
I don't know.
I also have like,
yeah. Tell us.
yeah, sorry. I have like, I think like what you were talking about like with latency was like pretty interesting too, because like if I remember correctly, right, like NASA's like entire like antenna infrastructure, right, is like shared across like every like mission, right? So there's like a lot of problems with like what's it the I forgot what it's called, but like the latency now, like scheduling and like network, right? So I think like looking at like that stuff would definitely be pretty cool, especially since like uh the server has like people who aren't just into like physics, but also like and like computational stuff or like mathematics, right? So there's definitely a lot of space in there.
I was going to ask about the latency, if you don't mind.
Yeah, go ahead.
Okay, yeah, because it caught my eye when you were talking about the multiplanetary stuff, because I've thought a lot about this too, specifically in regard to essentially governance and also like AI, like autonomy or whatever.
Mhm.
Essentially, if you had a bunch of different planets that were all far apart from each other physically, and there were some critical decisions that need to be made, you have to have some essentially authority that can make those decisions on that planet locally, or else, you won't be able to make the decision in time because you'll have to wait. You'll have to wait for them to tell you. And the same thing with AI. If you have some AI probe far away in another solar system, it needs to be able to make its own decisions because it just won't have the time to wait for its authority to speak to it. So I was just wondering if that was if you had that sort of interpretation with the latency.
Yeah, of course. I mean, it is kind of a hard problem, especially with current physics, because the speed of light is kind of the speed limit of the universe. That's kind of what everybody says, right?
Right, assuming you can't have FDL.
I mean, assuming you can't beam some tachyons, that break the light
Right.
barrier. Assuming that, but I mean, I'm gonna point back to the importance of this. There's a lot of mysteries that we don't know yet, that we have unresolved about our universe, about the structure of about the very structure and fabric of space time, and is breaking the speed of light, is the speed of light necessarily? I mean, it goes back to a very important question of this: is the speed of light necessarily a law? Right? Sure, it preserves space-time intervals. Lorentz Lorentz invariance does that, which is important, but there's a lot of I mean, it would be very scary if we discovered that, yeah, we can actually break the light barrier, and what it would take to rip apart the intermolecular forces of a proton with gravity, or there's a lot of things to talk about. See ya the giver. But yeah. I mean, sorry, that was kind of a rant, but your question kind of triggered me. Yeah.
Do you mind if I ask further about the tachyon stuff? Because I've been doing a lot of research into this stuff just in general.
Yeah, go ahead.
And I've had this loose theory. I've been working on my own project and stuff, and I've been sort of trying to disprove it. But one of the big problems was that it exists in flat space, and you have the speed of light, but it's the speed of light across all of flat space essentially. So you can have, if you think about a large intergalactic void or whatever, you have light going through there, and it's a non-uniform gravity field, so it just wiggles it back and forth. And so essentially, I was trying to figure out if there was any way that you could describe that. And so my idea was essentially that, and I discovered this was already sort of an idea, but my idea was just that if you had neutrinos with an imaginary mass, so that it oscillated in a way that let it just take a straight line. Essentially, you could still have the speed of light be the ultimate limit, but if it's in flat space, you can still have particles that are able to take a straighter path, and a faster path essentially over a greater distance than light. Anyways, that was where I was looking into.
Yeah, that's pretty exciting. I mean, then again, I think there's a lot of stagnation in the way that quantum field theory is taught. This is my first problem, which is that a lot of quantum field theory is taught in flat backgrounds. Most of the quantum field theory textbooks are all in flat backgrounds in Minkowski space-time, which is flat, like you were saying, flat space-time. And it's what happened to some of the revolutions that were happening with the formulation of C-star algebras in flat backgrounds. Or sorry, in curved backgrounds, or micro-local analysis across phase spaces. I think there's a lot of mathematical mystery and fundamental physics mystery as well. That flat space is cool, but I think we keep forgetting about curvature and how gravity influences particles in a gravitational field via this special type of curvature that comes from Riemannian geometry. And how it kind of there's a weird generalization of Riemannian geometry called Ehresmannian geometry, that forces internal gauge fields to describe the forces itself. And by the way, also gravity technically isn't even a force as well, but Lorentz covariance in curved backgrounds. Another really important thing to note as well is that causality. I'd have to relook at this, but causality in one dimension with just time and space, it works out perfectly fine. But there's some weird anomalies when you get to 4 dimensions, just in general with how Lorentz invariance gets preserved and all of these things, because it becomes topologically non-trivial. So anyways, everything that you said about tachyons and everything, like imaginary mass, like those things are pretty exciting questions, but also it takes a background as well in like understanding what the Higgs field is. And like if you were to plug in imaginary mass to the Higgs field, you'd realize that the free field and how it like interacts with the vacuum expectation value, like it would be unstable for imaginary mass. But then again, like the Higgs mechanism, or neutrinos, are not necessarily holding up to our expectations of how the Higgs.
Understood.
Yeah. So then again, there's a lot of questions. There's a lot of open questions. So yeah.
If you don't mind me asking one more thing.
Yeah, of course.
Well, so one of the things that I've always tried to see things in is just like the general overall sense, and it's always it seemed to me like if you look at like the ultimate fate of the universe, and either the expansion is accelerating or decelerating or is constant, I feel like that's one of the large questions, and of course that ties into dark energy and all of that. But the way that I was thinking about it was that if you did have a flat space and that light was able to be taking these longer paths, then essentially that could account for the redshift, and that you could account for a constant or even like a decelerating universe. According to observations, you could account for that in a model, and that to me, I've always seen people describe things as in terms of an expanding universe with a collapsing universe in the past, but they don't really sort of tie the two together. And to me, it's always seemed a little counterintuitive that if we just have an increasing acceleration, at some point you have to sort of tie it back into an eventual collapse. But the flat space to me seemed like it might be able to resolve that. So.
Yeah, a lot of the cosmological models that we have now are pretty much in trouble, especially with the DESI experiment. I think be on the lookout for, beyond, 5 sigma, like a violation of, the lambda CDM model. And that's important for, really, like, something that's super important to recognize is that it would change completely how we understand dark energy interacts with matter. And also, I would reference Landau and Lifshitz, Volume 2, Classical Field Theory. Go to the very last chapters and read it. I think you would find them very interesting, and play around with the ideas in there. I currently have a copy of it that's like it's like the second edition, and it's pretty interesting. But there's different editions, and they keep changing like the content of the book, but to account for like the modernization of cosmology and all these things. But yeah, so that's another thing I would recommend for you. I do this all the time. I just say Landau in chat. People are like, "What are you talking about?" And they'll be like, "Oh, Edmund Landau, the analysis guy." I'm like, "No, Lev Landau." But yeah. So.
Did you say you'll post this in like YouTube or Discord or something?
Yeah, this will be on YouTube.
Okay, cool.
Yeah.
I'll be able to.
Yeah.
I didn't write it down. I was gonna, but that's fine. I'll just rewatch it.
Yeah, it's all good.
Looking through your ring. Or close.
Yeah. Okay. Well, are there any questions in chat that I think are interesting? Thinker, I think you were looking at some of them. Did I miss any?
No, not really, I guess.
Okay, sick. Well, you can stop me if, I'm going to close it out, but you can stop me if there's anything else. But just the whole idea is the Institute doesn't need to know the answer. The purpose is to construct just a research graph. Just not a list of promises, but just a graph, if you will, and then maybe it'll turn into a nice geometric endeavor that will be very satisfying to see like emerge out of this little Discord. So yeah, if there's nothing else, then I'm going to end the recording, and this will be a. Oh yeah, go ahead.
Someone in chat asked something. You want to read it?
Yeah, or
should I?
Yeah. You can
Okay,
read it.
I can read it.
Yeah.
What can younger people who aren't in research about our new? How can we contribute to your Discord's research institute?
Honestly, the best way to contribute if you're younger is to sit down and read Apostles' Calculus, read Spivak's Calculus. Just immerse yourself, and ask questions. There's a lot of really, really intelligent people in this Discord that do this for free, because it kind of like it bursts out of our souls, right? So if you have, the best way that you can contribute is to catch up and familiarize yourself with the landscape that is physics, and be humble about it. Don't like think that you know everything. That's the best way that you can contribute, because none of us really know everything either. So yeah, that would be, just familiarize yourself with the reading list. There's the sheafification reading list, and there's also the portal reading list that I tell people that I reference all the time. So
Hello?
all right. If there is nothing else, I will conclude.
Hello?
It has been a nice time with you guys. Thanks for listening to me. Yeah. Oh, yeah.
He's talking.
Someone is saying hello.
Okay. What's going on?
Yeah.
What's going on?
Hello, can you hear me?
Yes.
Can you hear him?
Am I hearable?
Yes, you're hearable, my friend.
Yes.
Okay. Hi, Jet Bundle. I love your videos. I'm really happy that you're taking the initiative to make this institute.
Yeah, I mean it's a pleasure. I mean, yeah.
Yeah, and but like I am pretty serious about like researching all of these topics myself.
Okay.
And I just want to say I'm really happy to be part of this, and I do have some open research questions and things I also want to share, some results I have, and also some things I want to help on. And I really hope we can enjoy this time together, you know?
Of course, I completely agree, friend. So just make sure that you get familiar with the people who have been here for a while, and try to sniff out the people that know what they're talking about. That'll be your first assignment, your first skill to figure out.
Sure.
Yeah. So anyways, it's a pleasure. I'm gonna end the video now, and it'll be on YouTube maybe tomorrow. All right. Peace out.